Hello everyone, welcome to Simplified Geometry. Today we are going to see Theorem 6.4 of lines and angles. The theorem states that if a transversal intersect two parallel lines, then each pair of interior angles on the same side of the transversal is supplementary. Let us understand this by looking at this figure. Here, line L is the transversal. This transversal L intersect line M at point P and it also intersect line N at point Q. We are concerned only with the interior angles formed here. We are concerned only with the interior angles on the same side of the transversal. First, let us see where are the interior angles formed. See, these are all the interior angles. These angles are enclosed between these two parallel lines. These angles lie between these two parallel lines. Okay, so angle 3, angle 4, angle 5 and angle 6 are all the interior angles formed here. Okay, so now let us see interior angles on the same side of the transversal. Let us take angle 3. Okay, this is angle 3 and angle 6. Let us take angle 6 also. See, angle 3 and angle 6 are lying on the left side of this transversal. Am I right? This angle 3 and angle 6 are lying on the left side of this transversal. So, angle 3 and angle 6 will form one pair of interior angles on the same side of the transversal. We can also call this short as co-interior. So, angle 3 and angle 6 will form one pair of co-interior angles, that is angles on the same side of this transversal. So let us note that. So like what I said, angle 3 and angle 6. Angle 3 and angle 6 will form one pair of co-interior angles. And what's the other pair? Angle 4 and angle 5 lies on the right side of this transversal L. Am I right? Angle 4 and angle 5 are on the right side of this transversal. So that's the another pair, angle 4 and angle 5. Now there is a short trick to find these co-interior angles. You can actually see a C shape here. The C shape. The C shape stands for co-interior angles. Let me show that. See, I highlighted this C shape. You can see this C shape. So angle 3 and angle 6 are inside this C shape. Likewise, you can draw C shape here also. Okay. So the C shape stands for co-interior angles. Now what does the theorem say? The theorem says that if line M is parallel to line N, then angle 3 plus angle 6 equal to 180 degree and also angle 4 plus angle 5 equal to 180 degree. The meaning of supplementary angles is that if you add the two angles, you will get 180 degree. That's the meaning of the word supplementary. Now so if line M is parallel to line N, then angle 3 plus angle 6 equal to 180 degrees. 6 equal to 180 degree and also angle 4 plus angle 5 will also be equal to 180 degrees. So each pair of co-interior angles will sum up to 180 degrees. So we can call it as supplementary angles. Now let us take an example. Here PQ is parallel to RS. PQ is parallel to RS. So here the transversal AB is the transversal. It intersects line PQ at point C, line RS at point D. It is given that angle PCA equal to 65 degree. Now we want to find what's the angle of angle RDB. We want to find this angle, measure of this angle RDB. Okay, but from the theorem we just learned now, if PQ is parallel to RS, then the co-interior angles will sum up to 180 degrees. right? So angle PCA plus angle RDB will equal to 180 degrees. So let us write that. From the theorem we just learned now, this angle and this unknown angle will sum up to 180 degrees. So from the theorem, angle PCA plus angle RDB equal to 180 degrees. It is given that PCA equal to 65 degrees. So we will substitute in place of here. So 65 degrees plus RDB equal to 180 degrees. So angle RDB equal to 180. If the 65 goes here, it will become minus. So 180 minus 65 degree equal to 115 degrees. So we just got the this unknown angle as 115 degrees. Okay. So this is how we use this. Since this is a theorem, it has a proof. Okay. Now let us see the proof of this theorem. Why this theorem works. So what is given here? Given two parallel lines AB and CD and a transversal PS intersecting AB at point Q and line CD at point R. Now what is given? It is given that line AB is parallel to line CD. Now what we have to prove? We have to prove that the co-interior angles are supplementary. They sum up to 180 degrees. That we have to prove. So we have to write the to prove part also. So we have written the to prove part. We have to prove that angle 2 plus angle 3 equal to 180 degrees and angle 5 plus angle 6 equal to 180 degrees. Now let us start the. Okay. So for the lines AB and CD, see here, for the lines AB and CD with transversal PS, angle 1 equal to angle 3. What's the reason? They are corresponding angles. Am I right? So when the lines are parallel, the corresponding angles will be equal. So angle 1 will be equal to angle 3. The reason is corresponding angles axiom. Let us denote it as equation 1. Now see the figure again. For the line PS, this is the line PS. For the line PS, angle 2 plus angle 1. Look at these adjacent angles. Angle 2 plus angle 1. They lie on the line PS, right? So angle 2 plus angle 1 will be equal to 180 degree. What's the reason? Reason is linear pair axiom. Angles on a line are 180 degree. So angle 2 plus 1. So angle 2 plus angle 1 will be equal to 180 degrees because they lie on this line. So we wrote that here with the reason. Let us denote it as equation 2. Okay, now look at equations 1 and 2. In place of 1, I can substitute angle 3 also, right? Because they are also equal. Angle 1 is equal to angle 3. So in place of angle 1, I can substitute angle 3. So from equation 1 and 2, so from equation 1, these two equations, angle 2 plus angle 3 will be equal to 180 degree. Similarly, we can prove that angle 5 plus angle 6 equal to 180 degrees. So we just prove that angle 2 plus angle 3 equal to 180 degrees. That's all. This is how we prove this theorem. Now let us write the conclusion. Hence we proved that the sum of the interior angles on the same side of the transversal, not only this side, even this side also. Sum of the interior angles on the same side of the transversal is 180 degree. So we have proved this just now. So we'll write at the end, hence proved.